Okay, we have here a velocity selector. In order for the charged particles to go through undeflected, they must experience zero net force. So the magnetic force and the electric force must be equal in magnitude but opposite in direction. So we write BQV to be equals to Q times E, and then you obtain the magnetic field should be E divided by V. Alright, we are also asked to find out the direction of the magnetic field, given that the electric field has been chosen to be in this direction. The question did not state the charge of the polarity of the charged particles. It doesn't matter, we can just assume that they are positive charges. So if they are positive charges, then the electric force exerting on the charged particles will be downward in the same direction as the electric field. That means the magnetic force acting on the charged particles has got to be upward. And now I have here Fleming's left hand. So the thumb should be pointing upward because the thumb gives the direction of the magnetic force. And the current for positive charges going to the right, that means that current is to the right. So the middle finger should be pointing to the right. And so the index finger tells us that the magnetic field should be directed into the page. Okay? What if we have chosen the charges to be negative? If we have done that, then the electric force instead of down will be up, which means that the magnetic force instead of up has got to be down. Then would we have gotten a different answer? No, because we have the magnetic force that is down now, but when we are going to apply the Fleming's left hand rule, negative charges going to the right is the same as conventional currents going to the left. So that's one more change we have to make, and then with these two changes you realize you get the same answer, that the magnetic field is to be directed into the page. Alright, ta-ta!